completing the square, you have to add something to both sides to keep things balanced, and let's just go through it. You should remember it after I do it. So we're going to go x squared minus 2x, and we're going to move the 15 to the other side. All right, now we're going to add something here so I can complete the square. Does anyone remember what we add there? Mary?
Well, it's 1 because you do -2 divided by 2, and then you square that.
And then we square it. But to keep it balanced, I have to add the same thing to the other side. So we'd have -2 over 2 squared to the other side. All right, when I complete the square, I never ever finish this squaring thing, because what we're going to do is we're going to take this x and bring it down. And then we're going to take whatever's in that parenthesis and also bring that down. Well, that's -2 over 2, which is a -1. And then the square goes on the outside. So both of these squares are pushed together here. We never square it here. We just take what's inside. Then the other side is 15 plus, well, -2 over 2 is -1. -1 squared is a +1, so that's 15 plus 1, which is 16. Now to solve this, we take the square root of both sides. We would have x minus 1 equals plus or minus the square root of 16. Then I would add 1 to both sides. Let's bring this over here. We're going to have x equals 1 plus or minus the square root of 16, which is 4, which branches into two possibilities. Either x equals 1 plus 4, which would be 5, or x equals 1 minus 4, which is -3. That is completing the square. We need to know how to do that for when we get to vertex form. All right. First thing we're going to talk about is quadratic equation. Quadratic equation in standard form is a function that can be written as y equals ax squared plus bx plus c, where a does not equal 0. Every quadratic function has a U-shaped graph called a parabola. Or a parabola if you want to pronounce it wrong. If the leading coefficient a is positive, in order for a to be positive, that means a is bigger than 0. We have a parabola that is shaped up. The parabola opens up. In other words, it's a U-shape. And you think about x squared. X squared is our basic parabola. It is up. If your leading coefficient a is negative, that means our a is less than 0. Then the parabola opens down. Like that. So just looking at our equation, we know which direction our parabola is facing. Not only do we know it's a U-shape, we know it's either going up or it's going down. That gets us the start of our basic sketch of a graph. Well, we can actually get more from that equation. We'll hold that off for just a second. All right. So the vertex of a parabola is the highest maximum point if the graph opens down, and the lowest minimum point if the graph opens up. So in this graph, our graph is opening up. So its vertex is going to be a minimum. So that right there, let's change the color. Let's make it green. Vertexes like to be green. That is our vertex. If it's opening down, it'd be that top point. The line running vertically through the vertex is called our axis of symmetry, or AOS. So that dashed line that runs through it is our axis of symmetry, which we put as our AOS. We know both of these things based upon the equation ax squared plus bx equals c. We actually know both your axis of symmetry and your vertex from that equation. So let's go to this formulas part. If we are given y equals ax squared plus bx plus c equals y, then our axis of symmetry is going to be x equals, does anyone remember this? So, not bx plus c. Oh, that'd be nice, wouldn't it? I'll give you a hint. It's negative b over 2a. Over 2a. In fact, how does the quadratic formula start? Negative b.
Plus or minus square root of 4ac minus... Wait.
Yes. It's negative b plus or minus the square root of b squared minus 4ac all over 2a. The only thing we're missing here is the plus or minus square root of b squared minus...
Is that the vertex?
That's our axis of symmetry.
No, the square root section.
Not quite, no. That'd be cool. That'd be cool. So our vertex, so let's think about the vertex. So if my axis of symmetry is negative b over 2a. So let's go ahead and write that by our axis of symmetry. Our axis of symmetry is negative b over 2a. We should have x equals 2 because it is a vertical line. That means our vertex runs through where x equals negative b over 2a. So our vertex actually has a lot to do with our axis of symmetry. Our vertex is actually going to have an x value that's negative b over 2a. And if you ever want that y value, just plug in the x value. If you know the x value, if I say, what's y equal when x equals 2? You plug 2 in. So your y value is just plugging in negative b over 2a. And that's what f of negative b over 2a is. Plug in that x value. So our vertex, right there over there, would just be negative b over 2a, comma, plug that in and see what you get out. Your equation. I'm going to what? Yes, yeah, we'll do examples of this. Yeah. But really, it'd be kind of like if I had 2x squared plus 3x plus 4, and my axis of symmetry was 2, I would just plug 2 in for all my x's, and whatever pops out would be my y value. So I have 2 comma whatever that would be. Oh, here we go. We'll do an example. We're not doing them all. We're not doing all the examples. We're skipping the last one. You're going to do it for homework. It'll be fun. All right. We have an a, b, and c value whenever we have a quadratic equation. So let's go ahead and mark that down. So our a value is negative 2. Our b value is 4. Our c value is negative 9. Let's switch back to black because green just something else. Whenever I see an a value that's negative, automatically I think that's a graph that is opening downwards. It's a quadratic that's opening downwards. That's what you should think every single time you look for that negative or positive number. That means this graph would have a maximum value. Its vertex would be right there. Its minimum would be negative infinity, so it would have a maximum. Its axis of symmetry, we're actually going to do that work down below. So axis of symmetry is going to be x equals negative b over 2a. Well, we just got to plug in those values. Our b is 4, so we're going to have negative 4 over 2 times a negative 2. That's actually negative 4 over negative 4, which is just negative 1. Positive. You positive? I'm positive. Note how I write the axis of symmetry. I write x equals 1. 1 is meaningless. X equals 1 tells me it's a vertical line. So you need to write your axis of symmetry as x equals 1. That is something I can take points off of on your test. Right, Shane? All right, now let's get to our vertex. Our vertex is going to start off with 1. So if I'm already looking at my vertex, I know at the very least it's got an x value of 1. So we already did the start of our vertex. To get the rest of our vertex, we're going to plug that 1 into the equation. So we're going to have y equals, well, we started with, let's write the whole thing, 2x squared plus 4x minus 9. You're going to take that 1 value and plug it in for both of your x's, because you're saying what happens when x equals 1. That's what that 1 starts out as. All right, let's plug that in. We are going to have negative 2 times 1 squared plus 4 times 1 minus 9. Well, those are really just 1s. We have negative 2 plus 4, which equals a positive 2, minus 9 equals a negative 7. So our vertex is 1, negative 7. So whenever we're doing this, we're going to find our axis of symmetry first, and that's going to lead to our vertex. Axis of symmetry leads to our vertex. Our next one is x squared minus 10. Our a value is 1. What is our b value?
0.
It is 0. Yeah. Because this is really y equals x squared plus 0x minus 10, where our c is negative 10. Because our a is positive, this one opens up, so it would have a minimum. Our vertex would be a minimum, not a maximum this time. Axis of symmetry. I'm going to do that down below too, because I did leave room down there. So our axis of symmetry is going to be x equals something. Negative b over 2a. Well, because our b is 0, it really doesn't matter what our 2a is, but it would be 2 times 1, but no matter what, it would equal 0. Axis of symmetry is x equals 0, which means my vertex has an x value of 0. Now we just plug 0 in. What happens when I plug 0 in? What do I get out? I get negative 10 out, so we're going to have a negative 10. Let's go do that work down below, though. No? Okay, never mind. Y equals a 0 squared minus 10 equals negative 10. This stuff isn't rocket surgery. You just need to practice it.
Rocket science.
Oh, what? Crazy.
Silly.
It just takes practice, guys. It just takes practice in doing it. All right. The next thing we're going to talk about is vertex form. Use the vertex to find the vertex. Crazy. Note what we have. We have a times the quantity x minus h squared plus k. What does the h do? It's not just there. No, it has nothing to do with circles. What does it do? It either shifts it left or it shifts it right. What does the k do? Yeah. Moves it up or down, guys. Left or right means it has to do with our x value. It's how far left or right our vertex is moved. This is how high or how low our vertex is moved. So this h and k are actually our vertex values, where our h is our x value and our k is our y value. H tells you how far left or right you went. K tells you how high or how low that particular vertex goes. Note there is no mistake on here. If you have x minus h, your x value will be a positive h. That means if I have an x plus h, this will be a negative h. So your h will be opposite what's in there, kind of like our left to rights are opposite as well. So that's going to be important when we get to the next step, putting things in vertex form. But I'd probably have that written somewhere that is opposite. All right. We are supposed to put these in vertex form. It's like completing the square, but different. Look at your completing the square problem. What did you have on the left-hand side?
A y.
Or right-hand side? You had a 0. On this one, we have a y. We're not turning that y to 0. What that means is we can only work on one side of this equation. but we still have to keep it balanced. So if this was a 0, the first thing I would do is I subtract 71 from both sides. We're not doing that. Instead, we're going to keep everything on that right-hand side. We're just going to rewrite it slightly different. We're going to write this as y equals, and what we're going to do is we're going to think about this x squared plus 16x kind of all by themselves. So we're going to think of them as just being all by themselves on this side of the equation. I'm going to leave a little blank here.
Is that absolute value? Or
Yeah, it's just, we could put little brackets. I just wanted something to symbolize that I'm thinking of them differently than that plus 71. And I'm thinking of them differently because that's what I want to find the square for. I want to complete the square for x squared plus 16x. Well, what we're going to do is the same thing we did on the other side is I'm going to go ahead and add b over 2 squared, which would be 16 over 2 squared. When I completed the square in the first one, what I added to one side, I added to the other side so it stays balanced. I'm not going to do anything to the left-hand side, but I'm going to keep it balanced. How could I keep it balanced? Yeah,
subtract that number.
subtract it away. If I hand you $10 and then immediately take it back, I didn't lose any money. So that's exactly what we're going to do. If I added 16 over 2 squared, I am then going to subtract 16 over 2 squared. We added nothing. To put it into vertex form, you'll see. So I technically added nothing to this equation, which means I didn't change it. I'm just changing the way it looks. I'm just changing the way it appears. Because now I can go ahead and I can complete the square, which means I'm going to take down this x. I'm going to take this 16 over 2, which is actually 8, and throw it there. Throw their squareds up there. Then we're going to have plus, well, that's 72. So we have 16 over 2, which is 8. So this is 64. So we are going to have 7 plus 7.
So why is this 64 instead of 63?
Because 8 squared is not 63.
That's true.
Oh, what more? Odd number. Oh.
Yeah.
Yeah.
I thought you were subtracting 8 instead of 8 squared.
No. Okay. All right, guys. So I didn't add anything. So like Bree said, I added nothing. But I changed the look of it, so now it's in vertex form. Now I don't have to do any work to get the vertex. Our vertex is going to be what?
Negative 8, 7.
Yep, perfect. It's negative 8, comma 7, because this is positive, so it's going to be negative. The other way to look at this, when you plug negative 8 in, you're supposed to get 7 out. So this negative 8 makes this 0, which means you're left with that 7. This will always make this section 0. So if you're ever not sure if you have to do a negative or positive, plug it in. If I had a positive 8, 8 plus 8 would be 16. 16 squared plus 7 does not equal that 7. When you plug this in, you have to get 7 out. All right, what's my axis of symmetry?
Negative 8.
It'd be negative 8. Did you have to do any work for that? No. And we should say it's x equals negative 8 because it's the same thing as our x value of our vertex. And this graph opens what? Up or down?
Down.
Jacob?
Or no, this is positive. It opens up.
It would be open up. Yeah, don't listen to them.
You tried to trick.
It opens up. They sure did. It opens up. There's a positive A. Not only is there a positive A here, there's a positive A right here. If this right here is positive, it opens up as well. Our next one is 3x squared minus 6x. It's almost the same, but it's different. It's different because of what's going to happen. That's a vague statement. All right, we're going to still break this apart into 3x squared minus 6x. But I'm going to stop right there for a second and just have that negative 5 outside. So I'm not adding anything in because we can't. You can't complete the square unless it's a 1 in front of your x squared. We can't divide by 3 because if I did, we'd have y over 3 equals something, and I want y equals something. We're going to factor out a 3. So we're going to factor out a 3 of that one, and it's going to be y equals 3 times x squared minus 2x. I'm going to leave it blank right now. So I'm going to add in now minus 5. Now we can complete the square, and that is adding our b over 2 squared. Our b is negative 2 over 2, and we square that. Because I added it to keep it balanced, I need to subtract it. So we're going to subtract negative 2 over 2 squared.
Oh, the b.
I'm not subtracting it with the negative 5 when you added it in the parentheses.
Because I have to keep it balanced.
Oh, duh.
No, shh, guys. We can't focus. Yeah, so if I'm doing it on both sides, I add it to both sides. But if I only can work on one side, I have to add it and then subtract it. That's wrong, by the way.
Why?
You tell me.
Because you can't factor out a 3.
Well, I can factor out a 3.
I don't think you can do this.
You just quit.
You can't complete the square.
You can. Everything's right up until that very last thing I did.
Are you supposed to add it?
It's not balanced.
You're supposed to add it.
So I add something twice, and it's balanced?
No.
Where's the first one subtraction?
Oh.
Yeah.
Do you have to
It's a
multiply
negative.
that side by 3?
Oh.
Yes.
Wait, what?
I did not add negative 2 over 2 squared. I added 3 times.
Why?
Because the other one has it.
That's
So
stupid.
we move the 3 too.
Because technically this is 3x squared minus 6x plus 3 times squared negative 2 over 2 squared. So when you have that number out front, you have to throw it in there. That's why I had space right there. All right, now it's balanced. Now we're going to have y equals. We're completing the square, so we'll carry down that x. We'll carry down that negative 1, because negative 2 over 2 is negative 1. And then we square that. All right, then we're going to have minus 3. Now let's just do it all in one shot. So this right here would be negative 3 times 1. That would just equal a negative 3. So we're going to have negative 8. So our vertex equals, oh, thanks. It'd be 1 comma negative 8. Our axis of symmetry is going to be x equals 1. And finally, it's going to open up as well. Oh. And
Time to go.
no, I was making sure I had time to do the example. Yeah, Mary.
Why not include the 3 with the vertex before 1? Is it because it's technically like just 1 because it's the x minus 1?
Shh, guys. Say that again. I'm sorry.
You only, when you're trying to find the vertex for
Mhm.
like the x value, do you only count like what's in the parentheses, like x minus something or x plus something?
Yeah, we only count.
Okay.
It should just be like this, that whatever number this is, opposite will be your x value. And this outside will be our y
So you
value.
don't need to worry about the 3 then?
Nope, because watch this. When I plug this 1 in, 1 minus 1 is 0. 0 squared is 0. 3 times 0 is 0. 0 minus 8 is negative 8.
Oh.
You're actually looking for what x value do you plug in to make this 0, and what do you get out? A negative 8. This one is what x value do you plug in to get 0? Negative 8. What do you get out? 7. It's just we don't have to do all that work because it will always work like this. Otherwise, we would have had to do all that work. All right, now we're going to get to something that's more like your homework. Yay. Which is graphing the following quadratic equations and provide the following information. So first of all, which direction does this open? Yeah. Up. Thank you for raising your hand and everything. Y-intercept. Whenever you're looking for a y-intercept, you plug x equals 0 in. If you're ever looking for an x-intercept, you put y equals 0 in. So I'm looking for my y-intercept. I'm going to plug x equals 0 in. So that's going to give me y equals 2 times 0 squared minus 4 times 0 minus 9 is just going to equal a negative 9. Now note, y equals negative 9 is not what I'm looking for. I'm looking for the point. So this point would be 0, negative 9. Perfect. So let's go ahead and plot 0, negative 9. All right, now we're going to do our axis of symmetry. Our axis of symmetry is just x equals negative b over 2a. In this case, my b value is negative 4, so we're going to have a negative 4 all over 2a, which would be 2 times 2. Well, negative 4 is a positive 4. 2 times 2 is 4. Yeah. 1. X equals 1. So our axis of symmetry is x equals 1. Yeah.
And then our vertex can be, the first one's going to be 1, comma.
Yep.
Oh, yeah. From the...
But first I'm going to do my axis of symmetry right here. That is my x equals 1. But Jake is 100% correct. It gives us our start of our vertex. So our vertex, we can already start our vertex. My vertex is going to be 1, comma, something, and that 1 comes from there. Well, that means to come up with my vertex, I need to plug 1 into the equation. So for our vertex, we're going to have y equals, and we're going to have 2 times 1 squared minus 4 times 1 minus 9. And that came from plugging that 1 in for your x's. Well, 1 squared is 1, 1 is 1, so it's really 2 minus 4, which is negative 2, minus 9 is negative 11. So our vertex is going to be 1, negative 11. Surprise, surprise, your vertex better be on that dashed line you drew. You laugh now until I get the test and someone draws an axis of symmetry and they're like, vertex over here. And then they'll write, it opens up and it'll all of a sudden open down. Make sure what you write matches what you graph. And if it doesn't, tell me you understand that something went wrong. All right, so our graph is going to go 1, negative 11. And that's all you need to come up with a nice rough sketch of this parabola. Because this axis of symmetry is an axis of symmetry. What happens on one side happens on the other side. So if this point is here, I just go right across, and we're going to have another point right there. And so our graph is going to look something like... That's just a rough sketch of it. We're going to find our zeros. And when I find my zeros, we can have a more refined graph, but that's fine for our graph. All right, based upon this graph, what is our range?
Oh, no.
Yeah, what is it?
It is negative 11, comma, infinity.
Yeah, brackets, parentheses on the 11?
Brackets on the negative 11.
Perfect, negative 11 to infinity. Someone must have got that right on the test.
Mm-hmm.
What's the domain?
Oh, I know that one too.
How far left, how far right? Mary? That would be negative infinity to infinity. That is our domain and our range. All right, the very last thing we need to do is we're supposed to put it in vertex form and then come up with our x-intercepts, roots, or zeros. So our x-intercept, let me rewrite, or our vertex form, let me write down our formula. Actually, can someone read it to me? It's y equals...
2x squared minus 4x minus 9.
Cool, thanks, got it. All right, the first thing I'm going to do is I'm looking at just this 2x squared minus 4x. And I'm going to say I need to factor out a 2 out of there. I need to factor a 2 out front because I need to have a 1 inside those parentheses to make it work. So we're going to rewrite this as y equals 2 times x squared minus 2x, leave a blank, of minus 9. All right, what goes in that blank is b over 2 squared. So b plus b is negative 2 over 2 squared. If I was working on both sides, I'd add it to both sides. Since I'm not working on both sides, what do I need to do instead? Yep.
Subtract.
I need to subtract.
2 times.
Ooh, you got the 2 also. Yeah.
Does it subtract? Can you say it again?
Yes, I will. So we added it, so I need to subtract it.
Oh.
You have 2 options. Either you add it to both sides to keep it balanced, or you add it and then subtract it.
Oh yeah, 'cause we're adding nothing.
Yep, we're adding nothing. That's Bree put it best. You're just adding nothing. All right, now we're going to complete the square rule of y equals 2 times, carry down the x, carry down what's in the parentheses, so that'd be a negative 2 squared. We're going to have, yeah. Oh, I'm sorry. Yeah, you're absolutely right. I was trying to go too fast. Yep, it'd be a negative 1 because that would be a negative 2 over 2, right?
Yes.
Yeesh. All right, then we're going to have negative 9 minus, well, negative 2 over 2 is 1. 1 squared is 1. Well, negative 1 squared is 1. Negative 9 minus 2 is a negative 11. What would the vertex be based upon this formula? Yeah.
1.
Comma.
11.
1 comma negative 11. What vertex did we come up with?
1, comma, negative 1.
Yeah.
But
What's up?
What's the point of this? If we already have the vertex.
So I can put it all in one problem, so you have to do it all.
Okay.
So that when you get to the test and I ask for vertex form, you're like, well, you only made me do it once. I don't remember how to do it.
On the homework, like with these problems, can we just do this and then use that for like on the vertex?
So Nicholas said a very good thing. Can I just put it in vertex form and then just work from there? Sure.
Okay.
This is just 2 different methods to get your vertex. Either put it in vertex form and go from there, or do your axis of symmetry and go from there. The only good thing about finding your vertex this way is because the next thing is we have to find our x-intercepts, roots, or zeros, which we have 3 ways to do it. Factor it, complete the square, or quadratic formula. We already completed the square.
Quadratic's next. On the next problem.
No.
We don't have to do anything. We just plug a 0 in for our y.
On the next problem.
No.
Hang on. Let me finish this problem. All right. Now we're going to solve for x. So we're going to add 11 to both sides. Divide both sides by 2. We'd have 11 over 2 equals x minus 1 squared. Take the square root of both sides. We're going to have plus or minus the square root of 11 over 2 is going to equal x minus 1. I'm out of room, so let's finish this up here. I'm going to add 1 to both sides. I'm also going to flip the sides. Don't freak out. Don't freak out. We'll have just 1 plus or minus the square root of 11 over 2.
You gonna have time for the next one?
No, I'm not. I don't have any fun to get into it. Yeah. I'm okay with that, Mary. Yeah. No, Mary had a good point. She's like, do I need to simplify that? We're just going to leave it as is. This. I'm looking for just that. So we have 5 minutes to work on our homework.